So let's dive into this, polar coordinates. Okay, so probably should start off a little bit by talking about really what you're looking at. This is a polar graph. Now, let me begin with some very special points here on this graph. Okay, I want to tell you guys this point, let's maybe change that to red. This is your origin, okay? And that origin is called your pole. So I want to notate what this is. This is the pole, kind of like the North Pole, okay? It's a pole. And then right here, if you see this line here, okay? Let's emphasize this line. This also is important. This is called the polar axis, okay? It's a polar axis. So as you guys can see, what I really show without the graphics when I first start to discuss this, I'll tell people, okay, we're going to start with something called here, this dot here is called a pole. And I have this imaginary, horizontal line. We call that the polar axis, just like I just wrote down. This point here is our pole. And what we're going to start to define here are points. And I'll actually draw, when I show people this, an imaginary Cartesian coordinate system. Because really there's a relationship between this Cartesian coordinate system and actually your polar graph here. Okay? This is really the x-axis and you have the y-axis. So what's going on here with this polar graph, you do have the same, an imaginary what? X-axis over this y-axis. And I should say it's really not imaginary. It's actually, in some sense, it's even there. Okay? In some sense, I'll repeat, it's actually there, this x and y Cartesian coordinate. We just superimpose what we call a polar, a polar coordinate system over the x and y Cartesian, these Cartesian coordinates. And there's a relationship, and we're going to see that relationship. But I want to just remark that, yeah, if you notice, guess what? You might say, hey, if this was a Cartesian coordinate, isn't that a 90-degree angle? Okay, see what I'm saying? And that's why I have labeled up here, if you notice, I have labeled what? 90 degrees. These are degrees. And over here, we have 180. And over here, we got 270. And here, this would be 0 over here, or 360, okay? But you're not imagining the Cartesian coordinate system over this polar, coordinate system. It's not imagined. It's actually there. So it's under the hood. We work between the two systems. And one of the reasons why we need a polar system or polar coordinates is because it allows our work to become easier, not more difficult. So you're going to see a transition from the Cartesian to polar and vice versa. But always keep in mind, the real purpose of polar is to make things easier, not more difficult. But we have to learn some tools first. And that's what we're here to do. So we're going to start off today by looking at these polar coordinates. I'm showing you a picture of this graph. And it does come from Cartesian. There's a relationship. We'll see that. Today we want to plot some points. Okay? So let me give you a definition here of a point in polar. Okay? So definition. This is any point, sometimes we call that point P. And point P is defined by two values, r and what? Theta. Okay? R and theta. Now, really, this theta angle, we're going to consider a system where we rotate counterclockwise, and if we do, theta's positive, just like we've been doing. So I need an angle theta. This is what this theta represents. And I'm going to say to you, we also need a value called r, And anybody know what R might represent? R represents a radius. And this is the definition of a point in polar form. You need a radius value and you need an angle. Okay? And positive angles are rotated counterclockwise. And I'll say, by the way, also negative angles exist and they are rotated clockwise. So here's our notes. This is the definition of a point. So, for example, I might say to you, I'm going to start by plotting the point. For example here, this is P. P is 2, 0. This is not x and y. This is not an x coordinate and a y coordinate, okay? This is it. What do we have here? This is an r value. This is the radius. And then this is a what? Angle. So when you read this, you should say, my radius is 2, but yet what's the angle? 0. Again, it's not an accident. Where would 0 degrees be on this polar axis? We can draw a polar axis here. These lines are imaginary, okay? They're not exactly imaginary. I'm going to erase this. Let's try to determine where our 2, 0 would be. Start, I should say, maybe with the angle. Where's your 0 degree angle? Isn't it along this right here? If I said to you, isn't this 0 degrees? It's along what we call the polar axis. Okay. A radius of 2 really just means for us to move 2 units along the angle 0. So my radius value, if you can imagine a line just simply going 2 spaces to the right there, this location here is the location of what we define to be 2, what? 0. So here's my first point. It's on the polar axis. Okay, you guys okay with that? It's a positive radius value of 2. The angle is what? 0. Okay, anybody have any questions on this first plot? Okay, so you can imagine here really taking an imaginary line and rotating in a particular angle and then determining how far in terms of these units you actually go. So, for example, they may give you another one, and I'll say here's another example for a point. Let's say 1, pi over 4. Again, what this means is our radius is what value? 1. And what's the angle theta? What's theta going to be? Pi over what? Okay. So I'm going to take now a 45 degree what? 45 degree, I'm going to erase this. Let's take a 45 degree angle. How does that look? Something like this. Is that true? So I want to point out to you guys that this angle here can be thought of as pi over 4. Now, how far are we going to actually go in this case? Our radius is what? 1. So 1 unit, and I'll say here, if this here is 1 unit, then if we imagine here, this dotted line or a line rotated 45 degrees, 1 unit might be over here. Is that true? 2 units would be here, 3 units would be here, 4 units would be here. So we can say 1, 2, 3, and 4. The point I'm making is the point you guys are looking at, and maybe we should color this point, in black, I guess. 1 pi over 4 would be right here. So let's label this, if we can, as 1, pi over 4. And it starts to be a little messy, a little cumbersome, but let's kind of keep up with what's going on, erase some of these things, but the location in polar of 1 pi over 4, or 145 degrees, would be what you're looking at there. And that's just a point. Okay? 2 pi over 4 would be here, 3 pi over 4 would be here. They didn't ask us, but let's label at least one of these, 3 pi over 4. And I'm going to erase some of these things here to show you guys really how it would probably look. Okay? So, bless you.
Thank you.
This here again, here was what? 1, and this was 2. I'm going to erase the phrase polar axis as well. Clean it up a bit. Erase the phrase pole. As you guys can see, we're starting to plot these points here. Get rid of my pi over 4. Get rid of this. You are looking at, now we have how many points here? 1, 2, 3 points. 2, 0, 1 pi over 4, and then 3 pi over 4. We're plotting in polar coordinates. Okay, you need a radius value, and you need a what? You need an angle. All right, you guys okay with that? All right, similarly here, let's do something here. Let's look at some more examples because we got to be good with plotting points. You know, plotting points is where you start. There's a lot of information about plotting points. Let's plot another point here. Let's see if you guys are awake. I guess I can try something like this. How about if we try, let's try, for example, 3 pi. Let's plot that point. So we're going to go to our polar axis here, really this position here. And as you guys can see, if my angle here is what? Pi, right? This is my angles. This is pi over 4, angle here's pi. And what's my radius? 3. Okay, let's write this down. Our radius is 3. What's the angle going to be? Pi. 180, good. So 180 would be, remember, rotating. That angle's positive. That's a positive 180. So we're looking at here, starting on the polar axis, rotating 180 degrees. I now need a radius of how much? Let's do this. Let's say, okay, here's our, take an imaginary, or even if you want to say, let me take the polar axis or just an imaginary line and rotate that 180 degrees, pi. We're now going to locate what? 3 units. And let's kind of be consistent, meaning if this difference here is 1, then we can say 1, oops, I erased it. Then we can say, here we go, this should be 1, this should be 2, and this should be what? 3. So the location here now of my point would be right here. And I'll erase this imaginary line, and we'll label this point here. And you can say this is 3, comma, what? Pi. That's the location of this particular point. All right, you guys okay with that? Anybody have any questions on some of these angles here? Let me erase some of this to clean it up. Let's continue. Okay. We're going to plot points. Today it's really good for us to learn this because we're going to use these plotting points or use this technique in the future. So here's another example here. We're going to plot. How about if I say to you, oh, what? Let's plot 2 again. And this time we're going to make the angle, let's see, where would this angle be? How about if I told you guys, where's 2 pi over 3? So my radius here is 2. The angle here will be now 2 pi over 3. Does anybody happen to know what angle that is? Is that 120 degrees? You guys okay with that? All right, notice my radius is 2. My angle is 2 pi over 3. Where is a 120 degree angle located? Go back over here. Do we see a 120? Looks like it's where? Isn't that 120 degrees? That makes sense. Okay, so this is where 120 would be. All right, let's go back. if I can imagine, if you will, taking my pole possibly and rotating it 120 degrees, something like that. Is that right? Maybe it's along this dotted line here. And notice we're really saying that this angle here measures 120 degrees. That's the angle. Take our pole and rotate it 120. What are the units? What's the radius of this line here? 2. So let's be consistent. 1, okay. 1 and what? 2 possibly. Does that look like it's okay, or should be a little longer? Maybe 1, maybe what? 2. Here's my location of my what? Of my point. Okay, let's give the address. What's the address of this? Your R value goes first. It's what? 2. What's the angle? 2 pi over 3. And let's erase some of the stuff so it's not so cluttered here. And if you're watching the video, you would just go back. Okay, this is plotting points in polar what? Polar form. Polar coordinates. So that's kind of what it starts to look like here for us. Let's do some more. You guys ready to do some more? How about if I give you another example? Four comma what? 7 pi over 6. What's our radius? Radius is 4, good. What's the angle? 7 pi over 6. All right, let's write this down. My radius will be here 4, and then my angle theta is, what's theta? Is that 7 pi over 6? Okay, so where would this be in our polar world here? What is 7 pi over 6 anyway? Is that 240 degrees? Double check, is that right? No, okay, what is it? Pi over 6, isn't that 30? So what's 30 times 7? Wait, what 30, I'm sorry, did I say it right? I think I did. See, 7 times 30, what's that? There you go, 210. Okay, so 210, let's take a look over here. 210 would be, looks like over here. Is that right? It's in quadrant 3. So 210 degrees, alrighty. So it looks like here on my portion here, sometimes I think what I do is I'll write this what? This is my line. I won't put it, you know, really thick like that. I imagine this 240 degree angle. And now my radius has to be what? 4. So do you guys mind if I erase some of these by any chance? Since you have it in your notes, you could go back and even look at a video and say, okay, remember where they're at? You guys, because it's going to start to be a little more difficult when I say this is 1, 2, 3, 4. And you go, oh my God, it's right in the middle of this other stuff. So it is, but let's erase this. So I'm going to erase this point. You have it in your notes. And then I'm going to say here, let's stop right here. And I'm going to say here's the location of that point. Okay, and the address now is going to be, what's this address? 4, 7 pi over 6. And let me write it a little nicer. This is how we plot in polar coordinates. Okay, this angle will measure, we said 210 degrees. It's in quadrant 3. And as you guys can see, you know, it isn't so bad. Your radius here is positive. And we can plot some more, and let's do that. But, you know, I want to erase some of these values. Okay, does anybody have any questions before we look at some others? So let's kind of clean this up. There, that's a lot better. Let's go to you. Okay, there you go. What's this called right here? What's this location known as? That's a pole. Is that true? What's its address, by the way? Can you read the address? Good. 0 what? 0, just like in Cartesian coordinates. You see, what that says for us is our radius is 0 and the angle theta was what? 0. So if you took an angle, that is where what? Theta is what? 0. It's on the positive x-axis. You didn't rotate. So there's your angle, 0 angle, no rotation. You also have no radius, is that right? Because if you had a radius, like for example, what would be here would be 1, 0. Is that true? Here's my radius 1 with a 0 angle. Here's my radius 2. This is 2, 0. And then this will be what? 3, 0, so on and so forth. So that 0 degree angle, if I put my hand there on that line on the polar axis and I don't rotate, these are my addresses. Is that true? Anybody have any questions on all of these addresses? Let me actually emphasize them. Let's put it here. Here's where 1, 0 would be, 2, 0 would be, 3, 0 would be. And this is where the pole is, 0, 0. Similarly, if I said to you, can you tell me if I put these dashes here? Let's try to put some dashes here, here, and here. Let's look at these points. Anybody can tell me what are these addresses for these particular points now? Well, what's the angle? Pi over 2. How do we know? How do we know that's pi over 2? 90 degrees. Well, we know about it from our past. This is what? Is that 90 degrees? You guys okay with that? Anyway, good. Okay, what's your radius values? This would be then a 90 degree angle. Good. What's your radius? 1. What's the radius here? 2. What's my radius here? 3. In each case, the angle is pi over 2. Pi over 2. What's this? Pi over 2. Let's see if you're awake. Let me write it really clear. Okay. No, this angle is 90 degrees, pi over 2. My radius of 1, 1 pi over 2. This will be 2 pi over 2, and then 3 pi over 2. What do you think you'd have if I said to you, this angle, this location now? Let me erase this here. Let me erase this. What's my angle now? If I rotate counterclockwise, meaning, what's this angle now? What's the angle? Okay, 3 pi over 2. What's your radius, though? Remember, 1, 2, what? 3. This is positive radius values. So if I use the angle 3 pi over 2, which is what again? What's this? Isn't that 270? Rotate how? Counterclockwise positive. If I do this, then I could define my angle to be, what is it? 3 pi over 2. Let's find the radius values. Radius value will be what? 1. 3 pi over 2. 2, what? 3 pi over 2. And then 3, what? 3 pi over 2. So I want to point out to you, you're keeping that pole and you're rotating that pole. If you want to think of that as a line, if you rotate it, how? Counterclockwise, all those radius values there are positive as we see that. Now, I typically show this on the board and I put my hand on the polar axis and then I rotate. I put this like the, where the pinky is, this side, and we rotate And I can show people this elegantly on the board, and everybody understands that idea. Hard to do on this iPad. So just to let you guys know, we're rotating counterclockwise, and then that counterclockwise rotation makes us have a positive what? Angle. Nevertheless, anyone have any questions at this point? Because I'm going to erase some things. Nevertheless, you guys okay with that? We got these examples. I'm going to erase this. I'm going to look at the idea here now, not of positive angles, but of negative angles. Okay? So we're going to consider negative angles now. So you're going to say to me, what about negative angles? What if theta is less than 0? Or theta is negative? What do we know about negative angles? What's your rotation like for negative angles? Clockwise rotation. This is what you'll do. If theta is negative, you're simply going to rotate how? Clockwise. So our first example is going to be, if I said to you, can you plot 2 negative pi over 2? It's a negative angle now. Your angle is negative pi over 2. What does that mean if it's negative pi over 2? How do you rotate? Clockwise. By how much?
90 degrees.
Pi over 2, 90 degrees. That's right. So if I go to this picture here and you go, oh my God, I got all these points here. Let's erase this orientation. Right? Let's erase this. Let's erase this. We're even going to erase this counterclockwise theta being positive because we're not rotating positive angles. We're now doing what? Negative angles. You okay with that? What does a negative rotation actually look like? We're now going how? This way. By 90 degrees. Doesn't look so nice, does it? Let me do it nicer. We're going clockwise by 90 degrees, pi over 2. So if I take this pole and I'll erase it and I'll put it back. If I took the pole and I rotated the pole, how? Negative pi over 2. Doesn't it now belong over here? Say yes. Okay, get rid of that. Now, what do you guys notice here about my radius value? What's the radius? Is that positive 2? So when we write down, our radius is positive 2 though. What do you think that would be? Where would that radius of positive 2 actually belong? Well, rotate your polar axis, by 90 degrees. This location here would be positive 1, and this would be positive what? 2 here. Let me double check. That's right. So if you notice, you might say, you know what? Radius still is 2, but my angle is minus what? Pi over 2. That's the same exact location as what? You guys see the same location? That's the same location as 3 pi over 2. Yes?
Can the radius ever be negative?
It can be, and we'll see it. But not right now. It's a good question. We're sticking with this convention with positive radius here. Okay? But you're going to have a negative angle, right? So it's just very simple. Take the polar axis, right? Since this is a positive 2 over here, that point, if I rotate it now, how? A negative pi over 2, the radius is still positive because you're taking this, like I said, I do this on the board. You know, we'll take this, oh, I can't even reach, take this positive angle, right? And we rotate it. Everything here on my hand is still positive radius. Positive. That's the system. So, positive radius values. I want to say this though, and let's get rid of some of these things. This brings up a very important point about polar form here. That, let's highlight this. This address and this address, they reveal the same what? Location. You're right, the same point. They're at the same location here. So these points are not well defined, and that's going to be an issue for us in the future. And that kind of makes sense because we have this concept called coterminal angles. So even if I were to say to you, hey, guess what, by the way, I want you to plot a point called here. Where is maybe 3 negative what? 2 pi. What would you do now? You might say, you know what, Mr. Judge, 3, 0 is here. And I'm now going to do what? I'm going to rotate this, not clockwise, but what? Sorry, not counterclockwise, but what clockwise? How does that rotation look now? Let me say, oh my God, you take this particular point, I'm going to rotate this point, how much? 360, go all the way, ooh. Is that true? So what I'm saying to you guys is the location of 3, 0 is the same as 3, negative 2 pi. Because 0 and negative 2 pi are what? Coterminal. Or, take your polar axis again. Take that. Rotate that polar axis by a negative 2 pi, and your positive radius being 3 is at that same exact location. So, anyway, let's actually, I'm glad I made that point to you guys that these are the same. And let's erase a lot of this because it's starting to look a little confusing when you don't look at the particular details. Okay, so this one's gone too. This one's gone. So I'm saying to you here that this address and this address, they reveal the same location right here. Because these units here are 1, 2, and what? That should be a better 1, 2. This is 1, this is 2, and this is 3 for radius values, and they're positive. So there's a lot of points that are actually what? The same, that's not really well defined, but we just have to practice actually plotting some of these things, okay? So let's do some more examples for plotting because this is the foundation. If I ask you guys to plot now maybe for, negative 3 pi over 4, let's clean it all up. You first have to know, what is negative 3 pi over 4, by the way? Okay. What angle is this?
135 degrees.
I don't know. I got to figure this out. How do you guys figure out the angle? I mean, negative 3 pi over 4. We could do it a couple ways. Let me tell you guys this. This is one way I can do that. Do you guys know what negative pi over 4 actually is? Isn't it like something like this? This is negative 45 degrees. So if I go this way, this is negative 1 pi over 4. Now this is negative what? 2 pi over 4. And this would be negative what? There's where negative what? 3 pi over 4 would be. So you don't even have to necessarily, know the angle. I guess you do, 45 degrees, but the point I'm making is here's 1, here's 2, and here's what? 3. And that's where we rotated clockwise. So this is where negative 3 pi over 4 would be. What do we need now? Remember, we took this polar axis maybe, and we rotated it this way. Every angle on that purple portion there is every radius on that purple portion is positive. What are we looking for now? What's our radius? 4. So radius is 4 here. I'm going to have to do how many dashes? 1, 2, 3, and 4. So the location here of my point is right there. And we would say here, let's put it 4 comma negative what? 3 pi over 4. Write it nicer. This is not coming out as nice as I would like it, but and again, positive radius values. 1 here, 2 here, 3, and what? 4 over here. This is the location of this point here. What do you guys think? Is that pretty good? Not bad? All right, should we do some more? Let's give you an example. What if the point was 1/2 negative 3 pi over 2? Let's erase all this stuff. Okay. Where is negative 3 pi over 2? Well, the angle here again is what? It's a negative angle. What does our rotation look like then if it's negative? Is that clockwise? All right, so I'm going to say theta is actually negative 3 pi over 2 here. That means to rotate how? Clockwise by how much? 3 pi over 2. What does that look like? Well, here's 1 pi over 2, 2 pi over 2, is that right? And here would be 3 pi over 2. Are we rotating clockwise? Say what? Say yes. Is my radius positive? Do we have a positive radius? Say what? Yes. How do you know it's positive? Because the value here now is what? 1/2. All right. 1/2 comma negative 3 pi over 2. Where do I land in this picture? Look what's kind of nice here. We got 1, we got 2, we got 3. Where would the positive radius of 1/2 actually be? In the middle right here?
0.5.
Exactly. Right in the middle. Okay, you guys okay with that? It's not quite 1, it's half of 1. So my address here would be 1/2 comma negative 3 pi over what? 2. Pretty good? Should we do a few more? Okay, first got to plot some points. This is the key. Our point's going to be, how about if we say this? 5 negative pi over 6. Let's plot these points. 5 negative pi over 6. Okay, we notice our angle here again is what? Negative. Is that true? So my theta will be a negative pi over 6, and my radius is 5. Radius is positive right here. Okay. All right. What am I going to do? Let's erase this. What's an angle? Here's my polar axis in purple again. What angle is negative pi over 6?
It's a 30-degree angle.
Is that a 30-degree angle? So we're going to rotate clockwise by, you can say pi over 6 or by what? 30 degrees. All right, what might that look like? Maybe you want to go back up here. Doesn't it kind of look like this? Is that rotating 30 degrees? 360 to 330? So, okay, it looks like that in that direction. So we know that already. So, okay, this will be what we look at, I guess. We can do it this way. It's along that line, I guess, that rotation, right? So this is negative. Maybe you have to keep going. This is negative pi over 6. What is the radius again? 5. Is the radius positive? So it's going to be along this line here. So you're going to have to go out 5 dashes now. 1, 2, 3, 4, 5. There we go. Our point is right here. So this is my address of 5 comma negative pi over 6. There. This is radius 1, radius 2, radius 3, radius 4. So I want to give you guys at this point, you know, at least a fact to consider. And I already talked about it, but I want you guys to note the following, okay? That you may have a point called r theta. That point r theta is the same, equals. That's equal to, and sometimes your book will say this, they'll just write it, you know, we could get rid of the p. So this point is the same as theta, let's see if you guys are awake, plus what? 2n pi. Let's get rid of this 30. Is that true? Say yes. How do you guys know? Because my angle here, theta, and theta plus 2n pi, where n is an integer, aren't those angles coterminal? So your points are not well defined, and this is actually going to be, you know, like I said, it's going to be an issue. So we're going to, you know, we're going to consider that. We know that. So you might say to me, okay, Mr. Judge, what does that mean in this case here for this particular example? I got the 0.5, negative pi over 6. So here's my 0.5, negative pi over 6. If I have 5, negative pi over 6, let me ask you this. This is the same as 5, negative pi over 6, again, plus what? Plus 2n pi. So I can change my values of n, right? N could be what? 0, 1, 2, negative 1, negative 2. N could be different values. What that says here is that this point here of 5, negative pi over 6, if I just add, if I just add maybe what? Bless you. 2 pi. Can I generate another equivalent? I should say, can I generate the same location, okay, with a coterminal angle? The answer is yes. What does 12 pi become? Or 2 pi, I even told you.
It's going to be 11 pi over 6.
You're right. The final answer will be 11 pi over 6. Good. And, you know, that's a positive angle. No big deal. So you took the radius now of 5, and you rotated now clockwise 11 pi over 6, I guess. Is that right? Is that what we said? 11 pi over 6? Okay. What's 11 pi over 6 rotation? It looks like this. 11 pi. This angle is 11 pi over 6. So that's a clockwise, counterclockwise. I'll say it again. That's a counterclockwise location because you have a positive value, 11 pi over 6. Okay? This is positive. Counterclockwise rotation. Here, clockwise. Here, clockwise. So we could actually generate coterminal points. They have the same address, the same location. So location again will be right down here. So that would be 5 also. If we call it that, be 5 comma 11 pi over 6. Same exact location. Anyway, plotting points. Now you might say to me, what in the world does this mean? Why are we actually doing this? Well, I'm going to tell you guys how we can now define, and you guys ask, what about this concept called negative angles? Okay, or I should say negative radius. So I'll put that in red, and I'll say to you, what about negative r, a negative radius? Okay, what does this mean? Well, here's what it means. Let's start with an example. I'll tell you, you have to plot the point here, maybe 3 comma, let's say negative pi over 4. I'm sorry. Getting it backwards. We want a negative what? Negative radius. You okay with that? Good. Here, your radius here, your angle here is positive, by the way. But the radius here is what? Negative now. Here's my negative radius. R is negative, but theta is what? Positive. So the question now is going to be, what in the world do we do? Well, I don't know. We could leave this behind and let's actually start fresh here. Let's draw some axes again. I'm going to draw my imaginary, x-axis, imaginary y-axis. Let's actually make it look a little more imaginary. In the center again, this thing is known as the pole. And again, we can say this line is our polar axis. So we're going to start, by the way, by simply rotating our angle. What is the angle here? 45 degrees. So I'm going to do this imaginary line here where my rotation is positive. It's going to be, again, counterclockwise. And so here's my 45 degree pi over 4 angle. Is that right? Let's erase that. Bless you. Here's that theta is. Got the angle. Everyone okay with this? Now here's what I'm going to say to you guys. Just consider your radius to be positive. Okay? I'm going to rotate that polar axis positive pi over 4. And then you already know, I would say, that every distance here, 1, 2, 3, 1, 2, 3 here, is positive. Is that true? And then you're going to want to say to me, how do you define a negative radius? How you define a negative radius, ladies and gentlemen, is you take your angle theta, and we're going to add pi or subtract pi. It doesn't matter. So I'll point this out on the board, and sometimes I say this to people. Remember, theta being rotated positive pi over 4, this is where my palm is. If I look at the opposite quadrant, like you've been doing opposite quadrants, it's this other way. I can't really do it. My thumb will be touching the what? Opposite quadrants. Palm at pi over 4, rotate your hand the other way, opposite quadrants. What does that look like here? That looks like this. Let's not fall. Yes, it's in quadrant what? 3. This is where all the negative radiuses will be. Negative 1, negative what? 2, negative 3. So all you got to do is rotate your angle, whatever it is. If the radius is positive, it's on your palm. If the radius is negative, it's where? Opposite that palm, it's in the opposite quadrant. That's it. So when they say, where is negative 3 positive pi over 4? Here you are. Let's change that color. Here you are, here you are, here you are. This is location of what? Negative 3 positive pi over 4. Now, I could give you the definition of it, but, a picture is worth what? 1,000 words. And we could define that. It's simply, you'll say, here's r theta over here. And you say, what is this? Well, it'll be minus r, I guess, theta plus what? Pi. Anyway, we'll do more with this. Well, let's just first start with this, palm and thumb idea, because I think that's worked well for me in my life. It'll work well for you guys too. And, we'll do some more of these examples. Maybe we'll erase this here. Okay, some of these here, and we'll go back to our original. Is that too much to erase, you think? I think so. Let's look at some more examples of negative radius. So they say to us, let's plot. Yeah. Yes, and they will be. I will look at that. But let's do like negative 1, maybe pi. Okay, we'll get to those. Negative 1 and pi. Where would this be? Let's figure this out. Our angle theta, what's theta? Is theta pi? What's the radius? My radius is what? Negative 1. Good. Good job. Look at that. Let's figure out where this would be. To let you guys know, you may want to kind of think of it this way. This is how I go about all these. Draw my imaginary Cartesian coordinates, because I'm learning this polar representation. You go, okay, I know in the middle there, I guess I got this thing called a pole. Here's my pole. Okay, the address, by the way, of your pole is 0, 0. It's actually, there's more than one address, but we'll just start with that today. Polar axis on the positive x-axis. I'm going to rotate this how much? How do I rotate this polar axis? Is this positive? We rotate it pi, counterclockwise. Is that true? So you really have now your polar axis here. And then every value over here, to let you guys know, is positive. Positive 1 radius, positive 2. Here's 1, here's 2. Here's what? 3. Now, who can tell me? Since my radius is negative, where's all the negative radiuses in comparison to the positives? What do? What's the opposite? Should we add pi? Aren't we now over here? Say yes. So if I said to you guys, we rotated pi here, this is where my palm is. Remember I said palm? Rotate pi. Go where? On the opposite side where your thumb would be? We're back where the polar axis is. Every value here, this is now going to be what? Negative radius. Negative radius. Negative radius. Negative 3, negative 4, whatever. I only need negative what? 1. Good. Where is that? Right here. That's where your negative radius of 1 would be. So start with the angle theta, and notice again, every distance there is positive. Negative is on the other side, opposite angle, meaning 1 add 180. And this is the location now of your what? Negative 1 and pi. Now, you might say to me, like you guys already asked, what if they gave you both negative? What if they did this to you guys? And they said, give me a negative 2, okay, and maybe a negative 3 pi over 4. Where would you plot this location? Okay. Again, my angle here is what? Theta is negative 3 pi over 4. Is that true? Okay. So I already know. Alrighty. Let's sketch this. I got to know where negative 3 pi over 4 is, so I'm going to have to rotate this. I guess I rotate the polar axis, right? Negative 3 pi over 4. How does that look? Well, I already know this is negative what? 1 pi over 4. Oh, I think I've seen this kind of before. We rotated. This is negative 1 pi over 4. Negative 2 pi over 4. This is where the angle negative 3 pi over 4. It's negative, so we have to rotate this clockwise. Here you go. It's like rotating that polar axis, negative 3 pi over 4. Let's really think about this. Okay, you guys ready to think? Isn't this kind of consistent with what we've been doing? Is that consistent? We rotate that particular polar axis a particular angle, negative 3 pi over 4 now. So far, so good? What are these values here if I do this to you? What's this number? Good. What's this number? Good. What's this? Good. What's this? Those are all what? Positive. Outstanding. If I want the negative radiuses, where would they be? Opposite. You okay with that? They're going to be opposite. They're going to be this here. So I want you guys to think of it this way. This radius here is -1. This radius is -2. This radius here is -3. I can be a little bit. This radius is negative what? 4. It's opposite. Where do I put my dot? What do they ask for? -2, -3 pi/4. I look for what radius now? Negative what? 2. This is the location, or this is what we do when we have what? Both radius being negative and angle being negative. The key is simple. Rotate that polar axis, your particular angle, whether it's positive or negative. That's your starting point. And then notice when you did that, everything on that line has a positive radius value. Opposite that line, your radiuses are what? Negative. And that's the location here of this point. What do you guys think? Is that okay?